All right, what is up? Back at it the next day. So I'm committed to using this coil here. So I just removed the indoor coil down there. And I'm working at getting this fan assembly out. So one more screw down here is kind of a pain in the ass. But I'm kind of looking at it. I normally you would never take all this apart, you know, to get to a blower motor replacement. So obviously this would have stayed in the chassis. So I'm kind of looking at what they actually expected you to do to change this motor or the blower wheel. Obviously if you took all this down and you get the motor out, the wheel's going to come up. I did take the hub loose, but it's kind of on there pretty tight still. Here's this fan. I imagine it has to come off too. I'll probably take the shroud out, I'm guessing. I'm kind of wondering what the official, I didn't find a maintenance book for this that shows that. But yeah, this motor, I guess you just hope that it lasts the lifetime of this unit, because that's going to be a labor intensive job. I mean, remember, I've got all these brackets and cases totally off. So if you look at how this looked at the beginning, with everything attached, I mean, especially if you didn't pull it from the duct, from the power, from everything, and pull it out of the closet, I think it'd be pretty much impossible to replace the motor or the blower wheel. So even with it out and apart, I'm still looking and going, man, this is crazy. I got the whole stand loose. And reckon I should probably take this fan blade off and push it off. Maybe it'll come out and free up a lot of room, and then the motor will pull out. Because other than that, I'm like, how the hell do they expect someone to do that? I'm just trying to take it apart to get all that out of there. We'll probably use a different fan right here at this point, I think. Because this one ain't going to be efficient for... Okay, I just got it loose. So I pulled the fan blade off, which it came off the shaft actually pretty easy. But you can't pull the fan blade out because there's actually a ring that connects all the outside of the blades together. It's got a ring on it that spins. You can hardly see it. It's back in there. So that's there's a ring there. And then I was able to kind of pull the motor. So okay, so I guess you can get the motor out if you do that. So that would be the expected way. You still have to just take the sucker apart, and get that all out of there. Pretty hefty motor, actually. I thought it was going to be some rinky-dinky thing. So it's actually pretty heavy. I mean, this is pretty heavy, like a condenser fan motor. But, it is a 1/4 horse, 2-speed. Looks like one was, I don't know, it shows black and blue for the speeds. What a pain in the ass. I don't think I'm going to put any of this back together. If I use this chassis, I'm going to use it as just basically look like a condenser skid from, low temp or something, and like what I did out there, and build off of it. In the unit I'm using now, I did the same thing. The coil I'm using for an evaporator was a condenser. I turned it into a 2-circuit evaporator coil, and it worked perfect. So, all right, I got it up. I pulled that extra little loop out that was underneath. It looks like that. Just run there to help wick away any water that was underneath the condenser for some reason. Not a heat pump unit, but just straight cool. And this is higher, so it isn't like the condensate's going over there. Condensate is here, and then go down. What this was for, probably as a, I don't know, choke the air, but then it was coming out. And then, I guess, staying at that height. Or, you can kind of see where it was made to go. And of course over here, which I guess if it got high enough, it would go over there. And these are those deals that open up to the drain. I think a water touch. I don't know. Never really paid much attention to how those work. So I have this just up right now, so I can figure out how I'm going to do this. So I can't really just easily use these 2 circuits as I'm looking here now because, well, they do these crisscrosses right here. So it's really this one and this one that crisscross, or I have to take that out and change it up. And then down here, this connects 2 circuits to this bottom one before it comes out. However, it does it over there. And then this takes it over. Oh, this one and this one, yeah, they're all tied together right there. And I think that's where they hop over on this side. Yeah, this one, these 2 go sideways. So it might be easier to actually use all 3 circuits but it seems like quite a bit of coil. And this is the thing about like Frederick's crazy. Like this, like we looked up, is 10,000 BTU. But I mean, that indoor coil was pretty sizable slab coil for only 1 ton. I guess it might be about right. But you compare that to like a ductless unit, they don't have 4 passes. That's a pretty thick brick right there. And this one has 4 rows, 3 parallel, and then 1, you know, subcooler or whatever. When it was a condenser before I make it into a evaporator. So quite a bit of coil. There it is, 29 locked rotor amps. Pretty good amount. Let's go. Maximum main load 6,200 watts. I mean, that's definitely more than enough to start that compressor. Got this all apart. Kind of at another one of impasses. I like the one the other day where I'm like, do I want to repipe this? And then, of course, 2 days later, I was motivated to tackle that. Kind of figure out what I might want to do with that. But now I'm kind of at where, dude, this fan's going to be hokey. I can either put it all back together and use just the one side of the shaft, but that motor's going to be so inefficient. Just shit. So I'm thinking of maybe just using the compressor out of this, which was one of my first ideas, and get that carrier ductless unit out of the garage. The one I had put my guts of my current heat pump into, but then had issues because it wasn't it was losing too much heat in the extra piping. But that was before I realized I should cycle the circulation pump, you know, to maintain, you know, temperature in there and to build the pressure up faster. It would have worked if I would have done that, probably. But I had given up and put it back on the other little small skid thing out there. Here it is in all its glory. Got the panels off. So, is this motor the bad motor or the good motor? Oh, it's a bad motor. So, oh, didn't mean to do that. Here's the one that's currently got the bad windings in it. This looks to be another brand. And then here's some similar ones, but look, they all have like, you know, different type of mounting. However, I do believe I've swapped some of the guts on some of these before. So this here, get it apart. So here's your internals. So on here you got 8 magnets, and then you got like 12 poles there. And that's kind of, there's a couple different configurations of it, but that's kind of how this one is. Oh yeah, this one here, but I think this is another brand. This one actually has the module built into it, so you just can send in the 1 to 6 volt DC speed signal and directly once you power it up. Modules inside, but it's a little long, and this is a different brand, so I'm not able to swap parts. But I believe I tested and that worked. Okay, I didn't do it with the camera, but I turned on a power supply over there. Set it for like 30 volts. I think that's all that goes up to, and kind of just tested these, limiting the current, you know, set the current real low on that. And these would clock, you know, each time you energized, you know, one of the poles. It's actually always energizes 2 of the 3 at a time. Is how brushless DC motors work. 2 in series. So these are all working. This one's, does this even fit? Otherwise, I probably could make it work. That one has, like I said, a built-in module. Kind of tempted to try it. You can tell they're probably made by the same manufacturers, but the diameter of this was just a little different. And what it is these 3 motors here are, I think, from Daikin's or something. I think somebody gave them to me. And I don't know, they still work. So shit. Oh, and I have a couple other units out there that I could steal a motor out of for now. That is a carrier, but I don't know. Well, I tried to run it off this small brushless DC controller, but I'm only putting 30 volts into it. This runs on hundreds of volts, so just not happy. All right, back at it out here a little bit. Clean out some of the dirt that's sitting in the bottom of this thing. Dude, this is crazy that this thing was basically like was installed and then removed. It was like brand new, and I got my hands on it. I just wanted it for the shell to build my, heat pump into it, which I had done before. And then I had like put these expansion valves in here in my own little controller, and I was messing around with it, and it actually worked. I had repiped this using less of the coils, you know, for the smaller circuit, because I had that smaller compressor in here, right? It was like, so now I want to put the 10,000 B2 compressor in here, I think. This should still be about right, but I'm going to take out the expansion valve, just put a capillary tube there for those circuits. I think it's just feeding 2, and I eliminated 2, so I should be able to just remove this header and just put 2 feeders right in there. Is how that was working. Let's see. These 2 go up there. Actually, that's the liquid. Let me take that back. So that's liquid coming out, going back there. I eliminated a couple circuits. I think this might be the 2 that feeds in. Coming out of the expansion valve here. Yeah, that's what it was. So liquid comes in, hits here, goes to their meter there, and then the other direction is comes out and goes to the other one, which is feeding the indoor coil. So I'll have to revisit that. But it's just been sealed up and sitting out in the weather. I mean, look at this. Just from, I had this sitting out on the side of my house for all that time. Anyway, this motor doesn't belong to it. And this was like, this is 12 millimeter. Use my micrometer. But where this key was, it was just like a little bit more than a 10. And it needs to be like 10. So I just took the angle grinder and ground that flat spot down just a little bit, and the fan blade pushed right on. It almost seems like it might just stay on there. So I have my voltage doubler just to produce 300 volts DC. Turn this on, and it's gonna rock a while, and that's actually normal. That's how these fan motors start. Even in the untouched one out there, if you go watch it when it starts, they'll rock a while and then they'll get going. So it's like a little, takes its time to kind of figure out where the motor position is on those brushless DC motors. So I just have a potentiometer. You got like your 15 volts coming out, ground, and like a 1 to 6 volts roughly, you know, input. So I'll turn this up a little bit. See how much this thing's going to vibrate since I shoehorned in this other motor. Actually, I mean, the motor just bolted right in. It's just the shaft to play with. That's probably as fast as that fan will ever need to go. Okay, it's not really vibrating much at all. The shroud's not on there, so it's losing a lot of its concentrated airflow. But I'm sure I can make this motor go way faster than it needs to. She's moving. Pushing a lot of air out the side without that shroud on. It needs this to be around it. But that's way faster RPM than the motor usually is going to run. I wish I could have wished the motor that had the built-in, you know, inverter was good that I had. I don't even know where I got that from, but it didn't seem to work. So I do have one of these boards. I have a meeting to try to develop my own IPM module for small, you know, small motors like this. Never finished. I got the motor to actually run. I just never got it working with feedback. So I could probably almost program it, you know, good enough to get one of these motors just running to a fixed speed, you know, as long as it didn't lose sync. It's moving faster than it looks like on the frame rate of the camera. Anyway, there she blows. So I do know that part is good to go. I'll have to just build another controller for it. And yeah, got to rework the coil a little bit and just take that compressor there and drop it in here. Get my think I should be able to get my heat exchanger maybe to fit in here somewhere. Maybe up in here, I'm hoping. If not, it'll have to be on the outside of it, but I kind of want to get it all in there. So take a look at that. If that blade wasn't so far back in there, I'd be able to probably put it behind the fan. Maybe. Nah, there's not enough room. You know, being indecisive, that's how I am. So a lot of my stuff, you know, I'll do something, experiment with it and go, and then it'll give me different ideas, and then I'll like change the whole thing up. So this is all just because I was going to use that Frederick, but just getting a fan for this, I don't have anything that's just going to bolt on there. It would have been a pretty nice coil. Might as well put this back to you so it'll match the other shit I have out there on the side. It just looks like hell now for some reason, but from just being given up on for a while. All right, so I kind of gutted some things out here. And I set the compressor in place, and it bolts right in. Now I'm at another dilemma. It's like, you know, do I want to try mounting that heat exchanger on the outside and pipe it just going to be all hokey and everything? And kind of looking, it's going to be real cluster F to put it up here. I'm actually thinking of taking the compressor out, cutting off the compressor feet. No, it just works. And mounting that coaxial heat exchanger right at the bottom. That way I can maybe cook the two water lines right here short and sweet. I can notch around them and then easily pipe everything. It'll just pipe real easy, I think, if I do that. So I just have to do that. Plus I want to, once I get that heat exchanger, I usually like to encapsulate it in foam to hold the heat in because of, you know, what it's being used for. Need the heat. So, and it'll be inside this cabinet. And with the compressor on top, which then I could just wrap with a blanket or something. So that's kind of what I'm looking at doing now. All right, there's the 3 compressor studs. Just ground them off flat. Kind of a shame because it was the same footprint as the compressor I was putting in. So I'll have to make a new mount for the compressor after I figure out how I'm going to get that in this heat exchanger. Oh yeah, I shoehorned in that heat exchanger back in there quite nicely. This is going to get all wrapped and insulated anyway, so it's no big deal. Fan does not make contact. Kind of grab some old nasty, you know, steel brackets, bolts, just all the stuff I don't throw away. Kind of made this extension. Boy, that's freaking solid, man. And I just extended the compressor mounting bolts that I cut off up there. So there's that. Let me set the compressor on there. Oh yeah, dab down on there. Starting to look like something. Now the center of gravity or whatever is already horrible on a unit like this with the compressor on one side and not on the other. And so I just lifted it up 6 inches. So it's going to make this unit a little more sketchy to move around. But manageable. It's going to fit into there. This is the discharge. Just got to go in one side here of the, probably this side right here, the larger side of the heat exchanger. And the liquid side will just go over to the capillaries that are going to feed in this coil. I'll figure that out later. So if the hot gas is going in this side, because you got to counterflow it. So hottest gas, hottest water. So this will be the water inlet. Coolest being preheated by the coolest gas coming out. That's going to be condensed, refrigerant actually, by the time it gets here, with a little bit of bubbles. That's just, you know, how capillary tube systems will work anyway. And then the hottest water will come out here, being heated up as it goes with the hottest refrigerant. So this hot gas will connect here, liquid over there. So, yep. And this will be my evaporator. A lot of surface area. I don't know how bad it'll frost up. My other unit, when I did have it hooked up temporarily, it did freeze up. Frost up very even and everything. It was working great as far as the electronic expansion valves and the board and everything was. But I wasn't controlling my pump. I just had the pump just turn on. and with the cold water coming in, it just took forever for that unit to start heating the water worth of crap. So now that I know to cycle my pump, or that I've come up with the method I'm using now, shouldn't have any issues. And so get a can of foam and probably encapsulate that heat exchanger like I did my other one, and then just insulate these lines. Should work out pretty good. Well, I guess that'd be enough for today. Made some progress. It's kind of funny how I kind of get indecisive or on a spot, and I'll just kind of have to let it sit for a while and then come try something else or whatever. And then sometimes once I get going at it like today, then I'll just make a bunch of progress. So that's good. Now it's starting to look like it's actually going to be something. Need to get the basics all done, refrigeration wise and everything, so I can test the compressor and the operation and everything. And then after that, probably make another control for it. Might make the control more simple this time, to where it just turns on and off with a contactor, and maybe just run the pump based on liquid line temperature like I've been doing, which works most excellent. And maybe a defrost. I don't know. I thought maybe what I probably should do is just, I think I have a solenoid somewhere. Probably just tap into the hot gas line, just shoot it right into the evaporator, just do like, hot gas defrost or whatever, like you would like on an ice machine or something, rather than a reversing valve or whatnot. I might have a small reversing valve that might actually fit on this contraption, but we'll have to see. It's Phoenix. Doesn't get that cold, but when it's cold and wet, it will definitely freeze up, and the water heater needs to run early in the morning more than anything. So yeah, we'll see how I want to go with that. But that'll do it for this segment, I think. So don't forget to like, share, subscribe, and comment. Catch you guys later.